It's December 23rd, 2020, and we are here inside a little nameless creek in Gillespie County, Texas. And we today, together, are going to diagnose the ancients' continental terraforming. Let's begin. So here we have this diagonal seam. It's a 45 to the flow of the river, and I've documented diagonal seams in many videos, okay? And that line keeps going through many different time periods according to geology. Now you can see the diagonal construction of these primary layers, right? So that's a 45 to the flow of the river. Let's move back so we can see that more clearly, okay? So the creek, the flow of the creek is that way. We have that 45-degree construction. We move down. And we see again this 45-degree construction. They're building left to right, so we can see that 45 there, right? Same 45-degree sectioning. More diagonal seam construction, okay, in this primary layer. So there you have a 45 to the flow of the creek right there, through many different layers, through many different, quote, time periods, according to geology. It's one line. And that's a 45 that goes the opposite way of this 45. What we find is diagonal construction mixed with other angles, but the primary angles are diagonal. So these big, heavy primary layers have this diagonal seam, right? Not fractures, but diagonal seams, right? They're so integral that we can barely even see them. Here's one that's we can kind of make out here, but it's really integral, super strong. But they did build from left to right. They weren't magicians. They had to go section by section. So this is your section break right here. It's diagonal, 45 to the flow of the river. You can barely see the seam because it's so integral. Now, geology will call this a crack or a fracture, okay? That's the only way they can describe that. But look, see this seam? Watch what happens. Next layer, same line. So we know that that's not natural. Natural geology, the forces of nature, cannot make one straight line through many different time periods, and that's exactly what that line does. Here's another diagonal to the flow of the river, and we feel the regular quality of this section face right here. And that line, as I said before, goes all the way through all those layers. All these lines are traveling through many different layers. Impossible for nature to do. Nature isn't making vertical lines through its horizontal material, okay? Now we have a combination of angles, okay? We have this primary 45-degree construction. Then we have this right angle to the flow of the river. Right angle to the flow of the river. So mixed with the primary 45 is right angles to the flow of the river, to the flow of the creek. We see the side, the smooth, essentially regular side of this section here. We see the smooth, essentially regular side of this section here, right? That's the beginning of the diagnosis of any creek bank or river bank, is to look at where the section breaks are. There's the section break. How do we know it's a section break and not a crack? Because it's at a 45 to the flow of the creek, okay? Could a crack be at a 45 to the flow of the creek? It could. Could it transverse many different layers of geological material? It could not. It's that same line transversing those layers tells us this is terraforming. It must be terraforming. It must be conscious building, okay? So that's the beginning of the diagnosis, and then you can go to, well, look at the softness and hardness of the layers. So they had different hardnesses and softnesses, right? So here we have many different thin, softer, chalky layers below this hard layer, right? So this is slowly eroding out. And I've talked about ecological terraforming in many of my videos. whereby this sulfate-rich gypsum is washed downstream to fertilize vegetation. So this is conscious ecological terraforming. The harder layers stay strong, the structural layers stay strong, the soft earthquake mitigating layers slowly, daily fertilize the land, okay? And you can see that, of course, if you're not yet convinced that this is terraforming because you're new to my video series, well, let's look at these layers, okay? Now, if this was geological material, those layers would continue across, right? But they don't. That's one, geology would call it a stone, but it's concrete. It's one section of concrete next to a section that has many different layers in it, right? One layer, 7 layers, something like that. And then we have the straight lines that go through many different time periods, right? Many different, quote, time periods, because they're not time periods. This was all laid down at once. In other words, they laid down a section. Let's say they laid down this section with its corresponding 45s to the flow of the creek, right? Then they laid down that section. So they're laying down cakes, different layers. So these layers do not match this layer, and that's impossible for geology to do. Because the creek has eroded out the softer gypsum layers, as the ancients meant the creek to do, we're able to see below the harder capping layer of super hard, highly corrugated concrete. So the tops of those are highly corrugated. The top layer is highly corrugated. I call it a capping layer. And then we can see the diagonal construction of the sections, right? So we see the 45 to the flow of the creek. And we move to the next section because they did build left to right, or right to left, obviously. And we see the face of this capping layer, right? Very regular face right there. That's at a 45 to the flow of the creek. Now this highly corrugated material would be expected to have, if it was geological, natural, it would have incredibly angular, chaotic cracks in it, but that's not the case at all. It's not chaotic on the section face. So you can see the diagonal construction even in the creek bed itself, and this capping layer is plateauing. So I've called the stepping that the ancients do in their creek beds and riverbeds plateauing. So this capping layer is one essentially flat plateau, and then below it is other material, right? And then they'll keep stepping down using capping layers at the top. But what's interesting is that the capping layer and the material below it also has a diagonal construction, right? That then translates into the diagonal construction that we see in the creek bank. So it is a diagonal job, but we do see the diagonal construction. So there it is, and that's the flow of the creek, and there's the diagonals. All right, so we see them layering, we see them building in sections, we see the insistent diagonal construction, we see the point of that section pointing into the creek, telling us this is diagonal construction, this is built. We can move up here and see what else is happening. Yeah, we have another diagonal line to the flow of the river. Next to it, another diagonal line to the flow of the river. And this seam is so integral. It's joining together two sections with a slight little smooth-faced section there. So we can see the section on the left, smooth-faced, right? And then it's being joined to the section on the right with a 45-degree diagonal. Then another one, exactly the same, 45-degree diagonal, joining two sections together. So they built left to right. Their lines go through many different layers because they're building concrete cakes. And here's this point showing us that this is a terraformed object, that this creek bed is a terraformed object. It's telling us very clearly. And here's this section faces telling us that this is a terraformed object. Okay. It's a very beautiful day here in Gillespie County, Texas. It's almost Christmas, and it's quite pleasant t-shirt weather. And so I thought I'd come out and make another video. I have many videos waiting to be edited, but I thought, well, I should take my chance when I have the good weather. So that's what we're doing out here today. As I'm talking, I notice another diagonal seam, super clear. You know, we have the smooth face on the left, smooth face on the right, going through these layers, right? This layer and this layer are said to be, by geology, two different time periods, and yet this goes goes through both of them. And then on this side, there's only one layer. And geology has no explanation for that. Why are there two layers right there, and then suddenly only one layer right here? Well, we know that that's not geology, all right? That's the ancients using triangular sectioning, super strong building, because as any engineer will tell you, if you build in triangles, you're doing really, really strong construction, okay? And you can see the point, it's pointing into the creek with its 45-degree angles, right? Approximate 45s. Were they precious about their diagonal lines? Not very. So we have this diagonal line here, right? And then about a foot to the left, this other one, right, in the creek bed itself. But that then jogs over 6 inches, not perfectly straight, but it is diagonal construction to the flow of the creek. And then, you know, you can see the sectioning that they did. A smooth face on the right. Same angle. Same angle. And here's an unfortunate creature. Or fortunate not to have to live anymore in an age where ignorance is the common theme. We are moving into a golden age, slowly, slowly, slowly. And that age will be characterized by understanding. What don't we understand now? Well, we don't understand anything about our past. The universities have given us some ideas. They hand them out like facts, but they're really just theories. Geology is a theory, and it's not a scientific truth. It's just an idea based on a false premise that there were no advanced races in the distant past to build continents. But the evidence that accrues as we go out into the field, leaving the dusty, musty classrooms where professors encourage students to memorize names of minerals to get their geology degree, we see endlessly the diagonal construction, the sectioning of the ancients with their regular faces. Whenever we see inside a section, one that's broken out, we see the smooth, regular quality of the section, which a natural crack or fracture, as geology calls them, would not leave. So geology simply calls these joint fractures and says that's what we have. Why? Because we have a premise that it has to be natural material. These continents had to come into being through natural forces. That's the premise. So as full disclosure comes like a freight train down the tracks of future history, more and more people will see that advanced races did exist in the distant past, in the near past, today, and will continue to exist in the future. This diagonal line that we looked at earlier, so we have this diagonal line, right? And it's going through this layer too, right? Not just this layer, but this one with a smooth, regular section face. And this line continues on through all these layers. Smooth, regular section face on the left, and that line continues on. Smooth, regular section face on the left, smooth, regular section face on the right. And we have these smooth faces to the material, okay? 45-degree angle to the flow of the river. One line, okay? One line through many different, quote, geological time periods. Impossible. Therefore, we know it's terraforming. So, see that line? Very, very straight. Smooth section face on the left. Okay? Smooth section face on the right. Regular construction. Okay? And these faces don't meet, by the way. I've seen this many, many times. So this is higher. That's why we can see it. So then there's no erosion. There's no sense of erosion from rain or water there that's eroding this and not this. This was built just the way we see it. Insistent diagonals. Very strong building by the ancients. 45 to the flow of the river. 45 to the flow of the creek. So the creek is flowing this way, and we have the 45-degree angles of the concrete. So this is not stone, this is concrete. Sectioned concrete. One section, one section, one section. Who would do all this work for us? This is just one creek in one county, in one state, in one country, on one continent, on the planet. There are 6 continents. Who would do all this work for us? As we meditate upon the nature of the advanced race or races in the distant past who built Earth's continents, let's move with grace into the Golden Age, recognizing that we were not the first advanced race, but the last. We will achieve a golden age here on Terra, and this age will be characterized by an understanding of humanity's past on Earth, and it will be characterized by an understanding of the history of Terra herself, which is an archaeological history, not primarily a geological history, although geology does come in late in the day to erode artificial ancient concrete and to move material around in various ways. But the planet itself was built, and this understanding will give us a foundation for other understandings as we move into the golden time of the Golden Age. This is Jock Doubleday reporting from a little creek, a little nameless creek in Gillespie County, Texas, so small that no one bothered to name it. But the ancients worked meticulously to craft a creek that would work for the inhabitants of this planet who came after them.